Before any advanced computer vision model can work its magic, raw images need to be understood and prepared. This lecture covers image processing fundamentals, the basic steps involved in handling digital images. At its most basic level, a digital image is just a grid of numbers. For a grayscale image, each pixel has a single value representing its intensity, for example 0 for black, 255 for white. For color images, we typically use RGB, red, green, blue channels, where each pixel has 3 values, one for the intensity of each color channel. Before feeding images into models, we often perform operations, like resizing them to a standard dimension, for example 224 by 224 pixels, to ensure consistency. We might also convert color images to grayscale if color information isn't crucial, or vice versa if it is. Color space conversion from RGB to other formats like HSV, hue, saturation, value, can also be useful for certain tasks. Image augmentation is a powerful technique to increase the diversity of your training data without collecting new images. This helps prevent overfitting and makes your model more robust. Common augmentation techniques include random rotations, flips, horizontal or vertical, crops, changes in brightness or contrast, and adding noise. Beyond these, basic filtering operations are also part of image processing. For example, blurring using a Gaussian filter can smooth out noise, while sharpening can enhance edges. These operations are often used as pre-processing steps or even as part of custom feature extraction. Understanding these fundamental image processing techniques is the first step in preparing your visual data for sophisticated AI models. They ensure your data is in the right format and robust enough for training. Next, we'll look at one of the most exciting applications, object detection.